Okay, so again, to find a suitable delta, we're going to start by setting up the two inequalities from the definition. The first one, absolute value of x minus c, so x minus a negative 2. And the second one, f of x minus L less than epsilon. Again, you can always factor an x minus c out of your f of x minus L, so again we can factor an x plus 2 out of this equation. So that means the other factor would have to be a 3x, and to get a negative 10 we would have to have a negative 5. So now we need to find some number larger than the absolute value of 3x minus 5. So again, what we do is bound delta less than 1 or equal to 1, and we take it back to our delta inequality. And we manipulate it. So you can't manipulate it with the absolute value bars on it, so we take the negative of the 1 to the other side. And we get to an x by subtracting 2. So look at what bounding delta less than 1 did. It means we're looking at x between negative 3 and negative 1, and what we care about is x approaching negative 2. More importantly, it gives us a way of finding what's bigger than this equation here. So we need a 3x, so distribute 3. Subtract a 5. Alright, now we have some number, 3x minus 5, and it lives between negative 14 and negative 8. So anything between negative 14 and negative 8 will have an absolute value less than 14. Alright, so now we go back to our statement here from our f of x minus L. Okay. What is bigger than the absolute value of x plus 2? Delta is. What is bigger than absolute 3x minus 5? That would be a 14. So our f of x minus L is less than 14 deltas. We would like for it to be less than epsilon, so we set it equal to epsilon and solve. And we get delta is epsilon over 14. But don't forget your bound of 1. So at the end, we take delta to be the minimum of our bound and what we would get in the algebra.